Hello everyone. In this video I want to talk about something called collision theory. And collision theory is exactly what it says it is. It's a theory that says the particles must collide or hit or be close and collide in order to make reactions work. Okay? So the first part of collision theory says that all particles must collide to react. Okay, that's step number one. They must collide. They must hit. They must be close enough to influence each other somehow in order to make things work. Okay? The second thing is they must have enough energy they must hit hard enough. They must have sufficient energy to work, okay? If I can increase the collisions and make them hit hard enough, then they will react, and I can even make them react faster. So how do I affect this hard enough, this sufficient energy? I can turn up the heat. If I turn up the heat, I affect, not only do they hit harder, but they hit more frequently. If I add more stuff in there, if I add more reactant, then they hit faster, the reaction proceeds faster because there's more collision, simply because there's more particles. And the other thing too is I could use smaller particles. I can increase the surface area of these particles by grinding it up into a powder. Now there's more contact between perhaps the two reactants, okay, rather than having a big massive hunk of something. And the third thing about, so in other words, they have to be close. I actually screwed this up. The third thing about this is actually orientation. I need to change this on my slides, but the third thing is not proximity, but it's actually orientation. So some of the bigger particles, bigger substrate, protein, enzyme type things, they're not orientated the correct way. So in other words, they have to be orientated the correct way. So the one thing, perhaps the enzyme can fit into the substrate, okay, and make the reaction work. So if they're not orientated the right way, then they're not going to happen. It's not going to work the right way. We also see the reaction won't happen. In other words, we also see this perhaps with electrostatics, where big, bulky polar molecules need to have the right end. In other words, you can't have a positive end bump into each other. You have to have a positive negative end in order for the reaction to occur. Okay. So three things. Let me just reiterate. Number one, the particles have to collide to react. In other words, they have to be close enough. Number two, they have to hit hard enough and have sufficient energy to do this, and there's several ways to affect that. And number three, they have to be orientated the correct way, okay, or the right way, or orientated properly, okay? Now, we'll go over that in class. Now, again, some ways to affect these reaction rates or collision theory, to kind of expand on the collision theory, the physical state. So homogeneous reactants tend to work a little bit better or maybe differently than heterogeneous. Okay, so if reactants aren't in the same phase, the rate of reaction might be limited by the area of contact. So this might be a solid interacting with a liquid, perhaps. This could be a gas interacting with another, with a liquid. Again, the reaction might not work the same as if there were two gases or two liquids. Okay, that could increase the rate or decrease it if it wasn't that way. I already mentioned this one, but if I use more of a reactant, in other words, increase the concentration of those reactants, the rates will increase. Why? Because there was more collisions, therefore leading to a faster rate. Now, dialing up the temperature typically causes the reaction to happen faster. And by typically, I mean kind of always, but I told you I try to avoid that word. But generally, the reaction rate increases as the temperature increases because you end up with an increased amount of collisions. The particles move more, they have greater kinetic energy, they bump into each other more with the sufficient amount of energy, by sufficient or beyond the sufficient amount of energy, and therefore the reaction rate increases. The presence of a catalyst. We're going to talk about catalysis here in a little bit. Catalysts are agents that speed up chemical reactions. We typically use heat as a catalyst, but these are chemical catalysts. These are reactions that are facilitate a faster reaction, but are not used up in the reaction. They're not part of the reaction. They just help the reaction move a little faster. And the last thing is and this is only specific to gases, if I take a gas and I squeeze it and compress it and cause the volume to decrease by increasing this pressure on the gas, I cause the particles to be closer. And as they're closer, that means they're going to hit more. They're closer together. That proximity was an issue, was one of the points of collision theory, and therefore the reaction rate increases because there's increased collisions. So notice that increased collisions leads to increased rate, or equals increased rate happens 3 times. Okay? So the last thing here is I can increase the surface area. In other words, I mentioned this is breaking up the solute. Making a fine powder versus a big solid chunk, that exposes more of the solute to the solvent, and it increases the reaction rate. Okay? All right. That's it for this video. More on this in class.